Hello everyone and welcome. My name is Branko and I am a Creative Roads Manager here at MikroE. Thank you for joining today's NECTO webinar, which is all about smart farming and how to monitor and automate greenhouses with NECTO. Over the next 20 minutes, I'm excited to show you a practical, real-world solution I've built that takes the guesswork out of the greenhouse management. We will explore how you can use a simple clipboards and the power of NECTO Studio to create an intelligent system that monitors environmental conditions and automatically responds to them. At its core, the system does two simple but critical things. It constantly measures soil moisture by using the hydro probe clipboard, and it simultaneously tracks ambient light levels with the ambient 14 clipboard. Based on predefined thresholds, for example, if the soil gets too dry or the room gets too dark, it automatically triggers actuators. For watering, it activates a micro pump clipboard, just like over here. And for the lighting, it controls a relay 3 clipboard, this guy over here, which you can connect to a grow lamp. So let's start with the big question. Why does greenhouse automation matter? If you are a commercial grower or a dedicated hobbyist, you know that maintaining the perfect environment is key to a successful harvest. But it is a constant balancing act. Too little water and your plants perish. Too little light and their growth stalls. Managing this manually is time-consuming, and it is prone to error, and can be incredibly inefficient with resources like water and electricity. The challenge is to provide exactly what the plant needs, right when they need it. This is where smart automation comes in. It provides precision, efficiency, and peace of mind, letting you focus on the bigger picture while the system handles the minute-to-minute details. And that's exactly what I aimed to solve with this solution. I've developed a complete firmware application that creates a closed-loop control system for a mini greenhouse, just like this one over here. To get started, first, launch NECTO Studio on your system. Once the IDE is up and running, head over to the Package Manager, your central hub for browsing and managing ready-to-use projects. In the search bar, type Greenhouse or Automate Greenhouse Control to quickly locate the solution. When it appears in the list, simply click Install to bring it into your workspace. After the installation completes, just hit Open Example and the fully prepared project will be loaded in NECTO Studio, ready for you to explore, build, and run. What makes this solution special is its architecture. It's built in NECTO to be modular, data-driven, and easily expandable. This isn't just a one-off project. It is a foundation you can build on. Now let's dive into the code itself. I want to walk you through the source files so you can see how all of it fits together in NECTO Studio. Okay, the first file is the main.c file. This file is the control tower of our Automate Greenhouse Control application. Everything starts and ends here. The environment zones array at the top is our blueprint for what's being monitored. Each environmental zone links a sensor to one or more thresholds and specifies how the readings should be evaluated, whether an alert should trigger when a value goes above or below a limit. Here we have two zones, one for soil moisture using the hydro probe click, and one for the illuminance using the ambient 14 click. Before we dive into the main loop, let's talk about actuator parameters, because this is where actuator behavior is finally tuned. This small inline factor functions, actuator parameters default macro pump, actuator parameters default relay tree, and so on, preload the actuators with sensible defaults. For example, duration in milliseconds. It controls how long an actuator stays active. 2 seconds for the pump, but indefinite for lightning relays. Then we have an overcurrent limit, which is especially important for the micro pump, acting as a safety tripwire to stop operation if the current draw exceeds safe limits. Then we have cooldown in milliseconds, which adds a mandatory rest period to prevent rapid cycling of mechanical parts, extending actuator lifespan. And finally, we have a relay mask, which tells the relay tree-click exactly which relay on it or combination of relays to operate. These parameter presets make actuator control flexible and safe. And changing the watering duration or current limit, it really doesn't require touching the control logic. You just tweak the parameter function. Now, the application task function is where the system truly comes alive. It is an infinite loop that cycles through every environmental zone, pulling in real-time readings from each sensor. And for each sensor, it calls the read function pointer completely abstract, so the loop doesn't care whether it's reading moisture, light, or some future sensor type. Then the raw sensor data string is run through custom parse values, which extracts the numeric readings into a float array. Each value is compared to its threshold according to its mode. It could be threshold below or threshold above. This is where the decision making happens. A true alert condition flips a zone into an active state. And finally, when the alert occurs, the code looks up the zone's name to decide the corresponding action. For the hydroprobe alert, it triggers the micropump using the preloaded actuator parameters, which also enforce overcurrent protection. And for the ambient forwarding alert, if illuminance is low and the relay isn't already on, switch on the relay 1 of the relay 3 clickboard to power supplemental lighting. And finally, if no alert is active and the zone is ambient 14, but the relay was previously on, the system gracefully shuts it down. This approach makes application task highly scalable, and a new zone with a new sensor and the same loop will monitor it, evaluate conditions, and trigger actuators without rewriting the main control logic. Combined with actuator parameters, this design is modular, safe, and field ready for real greenhouse environments. Okay, we have described the main.c file. Now we are going to transfer ourselves to the sensor header file and sensor source file. These files are all about gathering data from the physical world. The header file, sensor header file, defines the interface for our sensors. Most importantly, it defines the environmental zone type structure I mentioned, which is the blueprint for our monitoring logic. The implementation file, sensor.c file, contains the nitty-gritty details. The sensor init function configures and initializes the hydroprobe click and the ambient forwarding click. You will even find a cool hydroprobe calib function that guides the user through a quick 2-step calibration for accurate moisture readings. The file also provides simple functions like read sensor 1 and read sensor 2. These functions read the raw data from the clipboards and format it into a simple human readable string, like soil moisture is basically 78%, for example. This decouples the low-level driver details from our main application logic. Okay, let's transfer ourselves to the parse header file and parse source file. This is a small but very clever module. Its only job is to take the human readable string from the sensor module and extract the number. The function custom parse values can scan a string like illuminance then colon then, for example, 50 lux, and pull out the floating point value, which is basically the 50.0. This is a great design choice because it means our main logic doesn't have to deal with complicated string manipulation. It just gets the numbers it needs to make decisions. It is a perfect example of writing clean, reusable utility code. Okay, we have finished with the parse, header and source files. Now I'm going to transfer myself to the actuate header file and actuate source file. Okay, here they are. If the sensor files are our system's senses, then the actuator files are its hands. This module provides a simple high-level API for controlling our output devices. The header, actuate.header file, defines an enumeration for all our actuators, actuator micropump and actuator relay tree, and a structure to pass in parameters like duration. The C file, actuate.c file, implements the control logic. The actuator init function gets the micropump and relay tree clicks ready. The star of the show is actuator activate. This single function can run the pump for a few seconds or switch on a relay indefinitely. It's also where the overcurrent protection logic for the pump is implemented, making our system safer and more robust. Okay, next one in terms of the files are logging.header file and logging.c file. Every good embedded system needs a way to communicate what it's doing. This simple module sets up the MikroSDK's log library to send status messages over USB UART. The logging init function configures it, and a global logger instance is available everywhere else in the project. This is how we see all those helpful messages like low illuminance detected, turning on first relay. Okay, I'm going to finish with the source and header files just like this one, and I'm going to transfer myself to the cmakelist.txt file. Finally, we have the cmake file. If you are new to NECTO, this file might seem a bit intimidating, but its role is simple. It's the recipe for building our project. It tells the compiler which of our source files to include. For example, like main.c file, sensor.c file, and actuate.c file. Then you will see lines like target link libraries. This is where the power of NECTO shines. It automatically finds and links the necessary clipboard drivers like click.relay3 and click.hydroprobe, and all the required MikroSDK components. You don't have to manually manage include paths or library files. NECTO handles it all for you. So, what is the real-world impact of a system like this? For a start, you get unprecedented efficiency. You are only using water when the soil is verifiably dry, and only powering a grow light when natural light is insufficient. This saves water, electricity, and money. More importantly, it creates an optimal growing environment 24/7. This leads to a healthier plants, better yields, and more consistent results. And because the system is so modular, it is incredibly easy to scale. You could add sensors for temperature, humidity, or CO2 levels, and connect actuators for fans or heaters, all by extending the existing framework. It is a blueprint for building a fully autonomous, smart farming operation. So, to recap, we have seen how to build a complete, intelligent greenhouse automation system from the ground up using NECTO. We started with a clear problem, the need for precise environmental control, and we built a modular solution that uses sensors to monitor conditions and actuators to respond in real time. We walked through the entire project structure from the high-level logic in main C file to the hardware-specific details in our sensor and actuator files, all tied together by the simple and powerful cmake file. I hope this has inspired you to think about what you can automate in your own projects. This entire solution, with all the source code we discussed, is available for you to install it via NECTO Package Manager, and you can try out by yourself. Okay guys, we are on to the Q&A session, so please ask anything that you want. And I think that we already have one question, and it is all about the addition of more sensors, right? So the question is, can I add more sensors to this system? And my answer would definitely be absolutely. That's one of the main strengths of this particular architecture. Each sensor is just another entry in the environment zones list inside the main.c file, and it is paired with its threshold and reading function. And you do not need to rewrite the main loop. You just give it the new zone, and it starts being monitored right alongside the other functionalities, the other sensors. So NECTO will automatically pull in the correct clipboard driver via the cmakelist.txt file, and you're ready to go without manual setup. Right? Okay. Since there are no more questions, I'm going to continue talking about this subject for some time, and guys, ask anything that you want, really. Okay, let me quickly step back and give you the high level flow of this solution, because it is one of the things I love about NECTO projects, NECTO solutions. They are clean and they are predictable. Just like clipboard drivers, they are definitely clean, they are easy to understand, and they are definitely predictable. So everything starts with a list. So I'm going to transfer myself to the NECTO right now, and here we go. Okay, and I'm going to open the main.c file. And what I want to say is that everything starts with the environment zones, right? Okay. And yeah, each zone definitely pairs a sensor with a threshold rule. And this means adding a new condition is as easy as adding another item to the list. And one of the nice things about how we structured environment zones is that it's basically a plug and play list. Yeah, you just insert some other clipboard, just like this one, for example. Okay, you have to increment the number of zones and you are ready to go. And that's basically it. Okay, and that's the beauty, because the loop that checks these zones doesn't care what sensor it's talking to. And I could answer the particular question how sensors are handled while in the application task loop. Just give me a second, and here it is. Application task loop, here it is. It's a huge one. Every sensor gets treated the same way. It's like each one speaks through the same translator. Okay, and each sensor has a read function pointer, right? And it really doesn't matter if it's reading soil moisture, light, or something else. Loop just calls that function. Okay, I'm going to transfer to myself so you can see me right now. Okay, and this application task is definitely keeps main logic simple and future-proof. And yeah, right. Okay, now I wanted to focus on the other thing. Once a sensor gives us a reading, we have to make sense of it, and that's where our parsing step comes in. And now I'm going to transfer myself once again to the NECTO Studio, and I'm going to open the parse function, right? And here it is. And we have one particular functionality over here, and that's it. Okay, one little function, custom parse values, might be the smallest file in the project, but it's doing one of the most important jobs. Sensors return friendly strings. For example, soil moisture is equal to 78%. And then parsing module extracts just the numeric part as a float. And this keeps decision logic clean, so no string handling in main loop. Okay, let me return to myself. Okay, so once again, once we've got a number, well, now it's decision time. Do we act or do we just keep monitoring? And when a value crosses the threshold, that's when the actuators come into play, but with guardrails built in. Okay, and the actuators have parameters sets just like duration in milliseconds, cooldown in milliseconds, and overcurrent limit as well. And for example, micropump can't run too long and has a cooldown to prevent rapid cycling. You have to understand this. You have to understand one thing, and this micropump clipboard is based on the 5 volts in terms of the voltage. So yeah, it cannot run too long. So you have to make sure that the overcurrent doesn't happen. Okay, and and what's the coolest part is expanding this system doesn't break anything, it just grows naturally. Okay, let me just see if there are any more questions. Not at the moment. I'm just going to continue talking, so please ask anything that you want, guys. Okay, I'm just going to explain some other things. So let's say you want to add a heater or even a CO2 injector, and that is definitely not a problem because adding a new sensor and actuator, you drop them into environment zones structure that I already explained to you guys, and basically the same loop, it is going to handle monitoring and actions without new control code. And yeah, that's basically it. We can also track the last state of things like relays. So if the grow light is already on, so let me just give you an example. Okay, here is the system. So once again, yeah, if the grow light, which can be run with the relay tree clipboard, and well, if the grow light is already on, we don't send another on signal. That kind of detail saves wear and avoids power glitches. And the best part is that expanding this setup is painless. You can add a fan, actuator, or a heater. You can give it a default parameter set. You can drop in the new environment zones, and the same loop will handle it. Okay, and yeah, honestly, NECTO Studio makes the whole process smoother because when you install some clipboard, some other clipboard, sensor-based clipboard, the NECTO Studio is going to automatically insert every single thing inside the CMake file, so you do not have to worry about the project configuration in terms of the CMake. So thumbs up for that. Okay, so once again, whether it's 2 zones or 20 zones, the architecture holds up. And that's the kind of future-proofing that makes embedded projects like this one so satisfying. Okay, I'm going to focus on the live chat messages. Nothing yet. So I'm going to answer possibly one more question. And that would be, could this run without NECTO Studio on just the hardware? And once you've built this project and programmed this firmware, from NECTO Studio, the hardware, this particular hardware, runs completely independently. You have a power source, of course, and no IDE connection is needed as well. So NECTO is just the environment where you develop, configure drivers, and flash the development board. After that, the greenhouse controller works as a standalone embedded system, reacting to real-world conditions in real time. Okay, guys, I think that would be it. So I am going to wait for just a few seconds if you have some questions for me. Nothing yet. Okay, I'm going to send you one particular link which you can use to learn about the upcoming webinar sessions in terms of the NECTO Studio. Okay, and let me just see it once again. And yeah, if somebody else has some questions, please do ask. If not, I'm going to thank you guys for tuning in, for listening about smart farming and how you can use NECTO Studio, how you can use clipboards, and how you can use some accessories to run simple and smart farming. Okay, we have a question. Okay, nice. One question, and that would be from the YouTube user, which is called Bob Hunt. Thanks for the question, Bob. And the question is, what is the chance of doing a seminar on adding custom boards? Okay, great question. We are definitely going to consider that. I could reschedule my plans, and yeah, definitely I can do that. If you have some suggestions in terms of the custom boards, please do send us some custom board suggestions, and I could do that for about 1 month. So for about 30 days, I could perform the seminar on adding custom boards. So yeah, great question. Thank you, Bob, for asking that question. Yeah, I could definitely do that. So maybe I could insert this theme that you have presented to me right now in some other webinar that I already scheduled. So that's a good start as well. So I could do that as well. Okay. Wow, nice. Great question. So you can send to, let's say, you can send something like this. Here is the email address. So please do note that email address, and yeah, you give it a go. Give me some suggestions, and I could perform such a thing. I could basically insert those custom boards into some kind of next webinar sessions, or create a particular seminar just about this subject. Okay, Bob, thank you for that. Yeah, if you have some suggestions, you can write down right now custom board suggestions. So please, yeah. Okay. Thank you, Bob. That was awesome. And thank you, guys. If Bob has some other questions, please do ask them right now. Yeah. And I'm going to send another link to you guys. Just give me a second. Okay. I think that you are aware about the web link in terms of the NECTO Studio IDE, but I'm definitely just going to send it to to this chat the link of the NECTO Studio IDE, because I want to make sure that everybody has this particular hyperlink. Yeah, that will be it. Okay, Bob, if you have some questions, please do ask them once again. If not, I could definitely close this webinar session, and I am definitely going to thank all of you guys who were watching this webinar session, and I'm definitely going to continue doing this because it's awesome, really it's awesome, talking about NECTO Studio and what NECTO Studio has to offer to you guys. Okay, if there are no more questions, I am going to end this stream right away. So once again, thank you guys, and I will be seeing you in the next one. Bye.